All right, here we go. I got to start my timer. My goal is to not go over like 20 minutes, so I might have to do this in a couple different videos. We are going to start to talk about the actual process of doing a conversion now from a mathematical perspective. So I always like to start this with a very simple example that people can just do off the top of their head. So for example, if, and this is the way I write my conversion problems, I have a starting value and then I draw an arrow and then put the units that I would like that converted over to, and then we kind of proceed from there. So if I said, okay, I want you to take 4 feet and convert it over to inches, most people don't have a problem with that, and they say, oh my God, that's simple, that's 48 inches. And then I ask them, okay, what did you do? Well, I multiplied by 12. And then I ask, why did you multiply by 12? And this is the answer that I get. Because 1 foot equals 12 inches. So I'm like, okay, makes perfect sense. All right, so let's do this one. I want you to take 48 inches and I want you to convert it over to feet. Now again, people go, math is super easy, no problem, that's 4. And then I ask, okay, what did you do? Well, I divided by 12. And then I ask, why did you do it? And they say, because 1 foot equals 12 inches. Or sometimes they'll say, because 12 inches equals 1 foot. Now the thing that I would like to point out about this is that you did mathematically 2 different things. In one case you multiplied by 12 and in the other you divided by 12. But when I asked for a reason, you gave me the exact same reason. So what I want you to think about here is when you do conversions in your head and you just say, hey, just multiply by this or just divide by this, the justification that you do one thing or the other because there's 12 inches in 1 foot really doesn't explain why it is you multiply in one case and divide in another. So I want to explore, why is it that you do this? Now, in order to explain this, at least in this simplistic case, we need to go to ratios. Because in math, if they had you do this, what they would say is, okay, I have been given 4 feet, and I would like to convert that over to inches so I can introduce something in the denominator that looks like this. But on the other side, what I need is a ratio that shows me how these 2 things are related to each other from a measurement perspective. Now, I am going to highlight this right here because this piece of information goes by a specific name, and it is called I can spell this, a conversion factor. And this is one piece of information that I would want you to remember. If someone ever asks you, what is a conversion factor? It is an equality that connects 2 different units of measurement. So our conversion factor is this piece of information right there. But what we do is we rewrite this as a ratio, but keep in mind that we have to have the same units on the top and the bottom as we do over here. In a way, from math, the thing that I reflect back on is the idea of similar triangles and setting up ratios to find an unknown. And it's kind of similar to that. So I end up putting that together, and then what I'm going to do is I am going to rearrange this so that it says X inches equal. Now, here's where I'm going to take you through this. I am going to take this through multiplication up so it is on the numerator. And that means I am going to take this ratio and I'm going to bring it over to this side, and what that means is that it gets flipped on this side. And then I'm turning it around here. So this is a little bit like in a math book where they kind of show you the finished product. What we get on the other side is an expression that looks like this. Now there are a couple things that I want to point out about this. First, this tells you why you multiplied, because the 4 and the 12 are both in the numerator, so in order to process this calculation, you multiply them. But the other thing that I want to highlight is the units of feet are diagonal from each other. And because of that, they cancel. So in the end, when we do this multiplication here, that is why we end up with inches on both sides. Okay? This is the explanation for all of this over here. Now, if we come here and we set up the other problem, and I'm going to set it up similarly, so I'll put 48 inches here over X feet. We have inches and feet here. We put 12 inches, 1 foot here. And if we rearrange this just the way we did on the other one, we multiply across by the X feet, and then we're going to bring it over here. What that equals on the other side is 48 inches. And this time, when this gets moved over, it ends up getting inverted, and we have, again, 1 foot equals 12 inches. So if you look at this as a mathematical exercise, now you have 48 in the numerator and 12 in the denominator, which mathematically is the equivalent of dividing. And this time, instead of the feet canceling, the inches cancel, so that we know the answer that we wind up with is going to have feet on it, just like we have over here. All right, now this is a very, very technical breakdown for the answer to the question of why do you multiply by 12 and why do you divide by 12 here? It's because when you set this up, the math processes in a slightly different fashion. Now, I'm also going to point out that when you talk about conversion factors and you go, well, how am I supposed to know those? Some of them you're just aware of because of growing up in a particular society. Like we know 12 inches equals 1 foot, 16 ounces in a pound, 4 quarts in a gallon. We're aware of a lot of them. But if you don't know a conversion factor that takes you immediately from one to the other unit, then you're in a little bit of a bind. But I want to show you a more complex version of this that allows us to explain something that I think you already know how to do with conversion factors in terms of writing them like fractions like this. But I'm gonna painstakingly take you through this because I think it's really neat. Okay, so I'm erasing all of this, and what we're going to do is we're going to change this a little bit, and I am going to say, instead of converting this into inches, which is a real simple thing, we're going to convert this into miles. All right? Oh, I take this back, and I'm not editing this, okay? I'm going to put another number here. let's say we're doing 49 inches. Okay, yeah, the feet to mile thing, somebody could probably tell me, oh, I know the answer to that because you know the conversion factor. For this problem here, if you were to say, I know how many inches there are in a mile, and some people are going to say, well, I could probably go figure it out. You're not allowed to do that. And if you actually knew how many inches there were in a mile, you're kind of a weirdo, in a good way. So what I'm going to do here is we're going to break this into steps, because some people might say, okay, I don't know how many inches there are in a foot, or excuse me, in a mile, but I know how many, the relationship between inches and feet, and I know the relationship between feet and miles. So what I'd like to do is I would like to do an inch to foot thing, and then I'm going to do a foot to mile thing. But if the only way that you know how to do this is through this ratio approach that we talked about a moment ago, this is what it would look like. And we've been through this. So we go with 49 inches. We need to get it to a certain number of feet, and we're going to use ratios. So we need inches on top, feet on the bottom, and our conversion factor that we know is that one. So if I go ahead and solve for x feet, again, we're going to bring this over to the other side so it's in the numerator, and then we're going to bring this over to the other side. What we're left with is 49 inches, and then in parentheses we would have the inverse of this, which would be 1 foot over 12 inches. And I pointed out already that the inches cancel, and we could get a number for this. But I am going to leave this as an expression because there is something super cool that I want to put together when we go over here. So when we're done here, we got a calculator, we could get a number. I'm not going to do that. I already mentioned that. So we're going to do the ratio thing again here. So what we're going to do is we're going to say, hey, I want to go from a certain number of feet, which is the answer to this, to miles. Now on the other side, we need a conversion factor. Now, some people kind of threw this out in class that they already knew this. The number is 5,280 feet equals 1 mile. Now what we would like to know is how many miles, and so I'm not going to call it X anymore. I'm going to call it Y. And that's our answer. Now here's where I'm going to change colors. Because, no, I don't want to do blue. Red is a nice contrast. So our answer for the number of feet that needs to go here is actually the answer to this here. So I am going to write 49 inches times 1 foot over 12 inches. Okay? That is this value going up there. Now, what I would like to do is I'm going to rearrange this just like I did here. And I do need to point something out here, that this foot and this one might be the same thing, because this answer here has already been expressed in feet. So since this guy canceled here and this guy canceled here, this guy here I no longer need because it came with the answer from here. Okay? So what I'm going to do is the same thing that we did before. I'm going to move this up here. So this is going to give me Y miles equals, now I'm going to have this 49 inches, 1 foot over 12 inches, and the inches have already canceled. And then I'm going to take this and I have to multiply it by the reciprocal. So that makes this that fraction. Now, you see some cool crap going on here? I want to know how many miles there are way back here in 49 inches. When I do this ratio twice process, look what I end up with for my answer. I have 49 inches. Then, because of the first ratio process, I used a conversion factor to get from inches to feet, and in that, my inches were diagonal, so they canceled. So I had an answer in feet. When I plugged that answer in here, and I processed it through a second ratio process, what I ended up with is this tacked on to the end, but check out the units. This feet cancels that one, and the unit I am left with is miles, which is exactly what I want here. Okay? Now when you say, how many times could we do this? We could do it however many times we needed to get through from one unit to another. But this is where I am trying to show you a shortcut, and what I'm going to do with this shortcut is I'm going to do it in a different fashion that most people would have been more familiar with. And I'm not even worried about calculating the right answer. What most people would tell me to do is, hey, start with 49 inches. Now, if I don't know exactly how to go from inches to miles, I can go from inches to feet and then feet to miles. But what I need to know here is 12 inches equals 1 foot. And what I need to know here is 1 mile equals 5,280 feet. And then, starting with my first value, what I do is I introduce a conversion factor. Now, I am going to go ahead and tell you, this is my, well, it's not my terminology, it's from a friend from years ago. He called these little conversion factor things magic H's because this H shape gives you a perfect numerator and denominator to put the values of your conversion factor into. Now the question is, do I put the 12 on top and the 1 on the bottom, or the 1 on top and the 12 on the bottom? And the answer to this, which I think you would have learned from chemistry when you did this process, is you need to put values of your conversion factor into the magic H so that the unit you're starting with, you want that to go away. That has to be diagonal where you put it in the conversion factor. So inches happens to be in the numerator, so we need it in the denominator. And the thing that we're going to convert it to is pretty much whatever we have a conversion factor for, which in this case is going to be feet. So we put that there. Then we can put the values, the correct values, where they belong. 1 goes with feet and 12 goes with inches. Now, once we're done with this, the inches cancel, and if we were to stop right here, that would be our unit on our answer, feet. But we needed to get to miles. That means we need another conversion factor. And this conversion factor gets rid of feet and it introduces miles. So in order to get rid of feet, we need that to be diagonal. Now, this is where I'm going to be very, very explicit. I know that in chemistry, when you do these long conversions, I hear people say, you always put the canceling unit on the bottom. No, you always put the canceling unit diagonal. And that is going to become important because later on in this year, some of our cancellations are not going to be numerator to denominator. They're going to be denominator to numerator. So the key word to remember is, and I'll capitalize this. Hopefully I'm spelling it right. The key word to remember when setting up conversions is diagonal, okay? So getting back to our problem, we could take feet to whatever we wanted to, but we want it to be miles. So we put miles here, and then we put the right value in the right place. 1 mile, 5,280 feet. And feet cancels feet. So once we calculate this number, that is the unit on our answer. So this is much simpler than that double ratio thing that we did earlier. But doing this is based on that ratio concept back in math. So again, when people talk about the math and nature, there's a connection. Now, I want to point out one more thing before I stop, because I am just over my 20 minutes. There is another mathematical principle at play here, which I love to point out. And that is, it's a conceptual one. And that is, what is this thing in a conceptual sense equal to in a numeric sense? Now, to give you an idea of what I'm talking about, if I wrote out 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, if those are my 12 inches, and then I tell someone, draw me a foot with this, this is the picture we're going to get. And the answer to, well, how are they related to each other is, they are exactly the same thing. Therefore, when we look at this in a conceptual way, what is that value equal to? The answer is 1. We are not changing anything about the size of the value. All we are changing is the unit that it is expressed in. And the same can be said here. I'm not going to draw out 5,280 of these and do it again. It would be a much busier looking picture, but the idea is that 1 mile and 5,280 feet are exactly the same thing, and so conceptually, this is equal to the value of 1. And in math, you learn the multiplicative identity property of 1, which basically says A times 1 equals A. And when someone goes, how many times can you multiply it by 1? The answer is as many times as you want, because 1 times anything is always the same thing that you started with. So when you look at this idea of converting and setting up these magic H's and putting values of conversion factors in them so that units are diagonal so they cancel, you can set up as many of these magic H's as you need to get the job done. So that person, that weirdo, who knows how many inches are in a mile, they could do this in 1 magic H. But if you didn't know that, then you could set it up the way we did, and you would still end up with the same answer that they did, without having to commit to memory how many inches there are in a mile. So this is beautiful blending of math and the real world. And I am going to make you interact with this all year long, because I want you to be sure you understand why is it that you're able to do this. Because when it comes to conversions, I hate it when people just say, oh, just multiply by this or divide by this. I want to see the setup that justifies why you do the multiplication or the division for that. Okay, so I'm ending this video, and I will have a follow-up that kind of is related to it, but not exactly the same thing.